Okay, so let's move on. My experience with big data started around 2000 when I was working in telecoms. And at that time, we were building a very big optical fiber networks until we had this famous dot-com bubble, and then all these companies went bankrupt, and I lost my job and I had to find another job. So this was the fiber network that we were building. And we basically were at that time ahead of the game. We were building a lot of capacity in network, but there was no demand. And now this capacity nowadays finally gets utilized by applications like mobile and big data. At that time, with one fiber pair, we could transport 1.6 terabytes of data every second. So there was a lot of capacity, but no one needed it. And this was why these companies, these telcos went bankrupt at that time. So at that time, when I started as a tester, life was easy. We had simple applications, websites, 2-tier, 3-tier. We had physical hardware, testing was done, waterfall style, as outlined. And yeah, time has moved on and things have changed a lot. And this way of testing is comparable of how they tested bridges in the old days. We just build a bridge, once it's done, okay, let's put a lot of trucks on it, do a load test, and hopefully it doesn't collapse. Well, we don't build bridges that way anymore, and we also don't do software development that way anymore. Nowadays we have the whole mobile, we have Agile, we have all kinds of virtualization, VMware, Docker. The picture you see in the top is the Large Hadron Collider. It's producing petabytes of scientific data every year. And one of the other big data applications is offshore windmill parks. Well, I'm from the Netherlands, so you understand I love windmills. So you might think, what has big data to do with windmills? Well, there was a Dutch company that made an application that all these wind turbines that generate electricity are being full of all kinds of sensors. All this sensor data is put into a big data database, and they compare these wind turbines. So, because if a wind turbine needs maintenance, you will see that the data from the sensors will be different than from the other 99 wind turbines around it. So this is how they use a big data application to get all this sensor data, and based on the sensor data and the technical skills from the maintenance engineers, they decide when they need to do maintenance. Because as you can understand, doing maintenance on offshore wind turbines is very expensive. You have to send someone by a boat and need to bring the right things. So this is one application of big data that, yeah, it's in the industry. It's something that we not directly think of when we talk about big data. Well, this is definition of big data. Maybe I've seen it before. Volume, velocity, variety. And I see a fourth V coming up in my project. And this is associated with testing diligence. It means that you basically also check continuously what's my input, what's my output. You can imagine that if one of these sensors from the windmill turbines, if it produces incorrect data, you feed it into your big data solution, you get incorrect reports. So you need to monitor, is this data within certain boundaries? You need to input, you monitor this on input level already before you start processing it into your big data architecture. And so this is becoming more and more important. Also, privacy issues. Hosting in the cloud. We have one of our customers, they encrypt all their big data in the cloud because they say, look, it's in the cloud, we trust our cloud provider, but if they get hacked, some security issue, we don't have any influence as a customer on their security measurements. So what we do is that we encrypt all our data before we send it to the cloud provider. These things are starting to become more and more important for big data. It's still very infancy. The security in existing smaller applications is more mature, and security measurements for existing smaller applications don't work for big data because it's a lot, it's faster, you want near real-time results. So this is the fourth V that I'm seeing coming up associated with big data. When we talk about big data, well, this is the landscape. This is all types of software that's being used in big data landscapes. Well, don't worry, I'm not going to discuss all of them. Lots of it is open source, but I will pick some of the more used, well-known parts of it. But yeah, there's a lot. There's really a lot to learn if you're active in this field. Thank you. So, let's say we want to do performance testing. And we would do it the old way, like in the times that we were developing waterfall. Okay, what do we need? Well, we need a big data production cluster test environment. No problem. How are we going to generate the load on that one? I need a load generating cluster that can supply me with all the data. And then I need data. Lots of data. Terabytes, petabytes of test data, feeding it into my test cluster. And this is a problem, because with the new government regulations, you have privacy things, you can't put real names, bank accounts, whatever into there. You need to use anonymized data. If it's sensor data from these wind turbines, maybe we could deal with it. But the problem is, it's just not feasible. It's too expensive. It's too expensive to do performance testing on big data this way. These production clusters, they're not cheap. Load generating clusters are not cheap. Test data management is a nightmare if you have this amount of test data. I can give an example. I was doing a project for Staples. Staples is a large retailer of office supplies, and we wanted to do end-to-end performance testing. So they have a web shop, then they have an SAP solution, then they have a warehouse system, and eventually from the warehouse you will get your order that will go to the customer. So let's say I want to do end-to-end performance testing. Okay, I need customers in the web shop. Yeah, no problem. I need articles in the web shop. But these customers also need to exist in the SAP system. And then, of course, to be able to place orders, these customers need to have a credit. If you don't have credit, you can't order. And when we look at the articles, they need to exist in the web shop. Good. They need to exist in SAP, because otherwise you can't order them. And the last step is they need to exist in the warehouse as well, because otherwise the order will fail, it will not be processed. And then the last step is, of course, that you need to synchronize all these things. There were customers, there were corporate customers, they have different pricing schemes. There were schools that have different pricing schemes. There were some special customers that can order only certain articles. So how long did it take to set up all this data for only 100 customers in all these systems? 2 months. It costed 2 months to align with all the owners. The web shop have different people. The SAP systems, different people. The warehouse, different people. So I had to talk to all these people to get my data aligned to do a performance test placing 20,000 orders for 100 customers. So if we would do like this on big data, it would not be feasible. And it's the way we test the bridge. You know, it's like, oh yeah, we built everything, and then in the end we put a load of trucks on it and just see if it doesn't collapse. You want, especially with this type of solutions, you want to know it will be performing before you have completed your whole infrastructure and your whole tools and everything. So this is not feasible. It's nice for smaller applications, but when we talk about big data, we need to do things differently. So if we step back a bit, how do we build bridges nowadays? We have all kinds of software where you can actually already build the bridge, emulate the bridge, check what happens if the temperature goes up, goes down, if there's a certain amount of wind blowing, before we start building. So once we have it built, you're almost 100% sure that it will take the load. Of course, you will do a load test, but you will already have the feeling by design that it will perform and it can take the load. So if we translate this way of working to our big data solution, we need to dive a bit into architecture. And what makes big data big? It gets lost. You have lots of people twittering, Facebook, messages, like these sensors from these wind turbines. Every second they feed you a value. And if that goes on for hours, you have a lot of data. You end up with big data. But the core thing is, it's fast, and that's why it's big. I looked there's some website, Internet Live Stats, and looked up some figures. And you see like 50,000 Google searches every second, Twitter, Tumblr posts. So big data becomes big because it's fast, and you get a lot of it. And if you want to analyze it, make decisions, predictions, then you need some structure that can handle this amount of volumes of incoming data. And this data could be anything. I mean, I take examples from internet applications, but this could be sensor data, this could be all kinds of data. So, yeah, what do we do in our big data solution with this data? Well, first we take it in, we put it in a database, we make decisions on it, we run reports on it, we run forecasts on it, and we do this to make a decision. Where are you coming from? What are you using? If you, maybe you look up on Google some product. And then the coming days you will find that if you visit certain websites, you certainly get ads because of you looked up a product earlier. So it was recognized you have done in the past a search for a certain product, and then at the moment you move on a few days, you suddenly get offers for this product. So this is a part of big data. What were you searching for? Someone has captured it, and based on that data, they will provide you a link to this product you were looking for. Good. We're getting a bit, we go a bit into the technical details. This is the Lambda structure, and it's basically two things. We have a real-time layer, which directly processes the data. So you can see very fast, hey, everyone is suddenly buying shoes or is looking for a trip to Paris, all kinds of things. And you have a batch layer, which basically works over all the data you have over a certain amount of time, and that will give you the long-term view. And this batch layer is operating on the historical data storage. And then you have, of course, a serving layer that's a kind of dashboard where you look, hey, what is my short-time predictions, what's trending, what's happening, and you have also your long time reports, like how many products I did sell and how was that related to which customer and so on. The other is Kappa, and here they have combined the real-time and batch layer. And the benefit of it is that you don't need to maintain two types of software. If you had the previous example, for the batch layer, you have kind of software scripts that run, and for the real-time layer, you have them as well. Where at the Kappa infrastructure, you combine them, so you have less maintenance, and you also see again the historical data storage and the results storage and the queries. So yeah, this is all a bit high level. Let's have a practical example of an implementation of the Lambda layer. You can recognize that. Travelbird is a Dutch company, and if you go to their website, they will come up with suggestions where to travel to. And they use a lot of data from you. What they do is they look which browser you're using, which operating system version you're using, where you're coming from, what's the time of day, what's the current weather, what's the weather forecast, what are other people looking for as travel destination, what were other people at the same period last year looking for as travel destination, what are trends. All this data they feed into their big data architecture, and you see here the split part of the data goes to the top. This is Hadoop, this is batch processing, and so this is the historical data processing, and you have the real-time layer, and that goes to real-time database, real-time view. This real-time view gets data from the historical layer as well, and then it's presented on a dashboard, and they can see what's trending, what people are looking for, where people are coming from, and how to sell more trips. And this was part of a presentation that was given at so-called Meetup. Any one of you heard from Meetups? Yeah, I see a few people. Yeah, Meetup is really great. And why is it great? Because you can actually meet with people in the field that are using this technology, and you can ask them. You know, as an example, let's say I want to be a carpenter. Okay, I go to the library. some job offer, yeah. No, I just turned it off. But yeah, let's say I want to be a carpenter, and I go to the library, I get some books, I go to a tool shop, I buy some tools, I buy some wood, and I try to make a cupboard. It will not be so great. It will look like a cupboard, but you can't learn everything from the books. And this is great with Meetup, is meet people who are actually using it. So if I want to make a cupboard and I want to be a carpenter, I would go to a real carpenter and ask him the tricks of the trade. Teach me, show me, and I would get much more knowledge than only from getting it from the books. So Meetups is really nice to attend if you are working in this field. And you will also notice that you will meet other types of people. Not only testing people, you will meet data scientists, developers, technical people, engineering people. And as you can see, in the Netherlands, we have quite a few of these meetups related to big data. So of course I looked up in Vilnius as well. Now, there's not so many, but there's still a few. So if you're interested in this work, you want to know more, you want to get practical examples, you have questions, I really suggest, it's very easy, visit them, talk with the people, get the knowledge. You know, you won't get everything from the internet. You won't get it all from the books. Attend these meetups. It's what I regularly do as well. I'm not a data scientist. I'm performance testing, performance architect, but still I meet with them to get their knowledge, see their presentations, see what's happening in this world, what they're working with, because it's a very fast world. There's all kinds of software. I showed you earlier a picture about the whole big data landscape, and it's continuously evolving. So if you active in this area, I really advise you to meet up with these people. So we're going a bit into the technical stuff again. For the fast data, and this is what, for example, Travelbird was using, is they are using an application called Apache Storm, and it can process, it's designed to process data really fast, and it's also running a kind of software. So Storm is the infrastructure, and you have developers that actually build small pieces of software on top of it specific for your application to process all the data. So what we find there is a tuple. A tuple is basically, it's just data. It can be any data. It can be Twitter data, it can be sensor data, it can be Facebook data, it can be your browser data, any data. Then we're getting a stream. This could be a Twitter stream, this could be a stream of data with all this sensor data, and then we get a lot of streams together, and that's called a sprout. So this is the infrastructure we are talking about when we talk about this big data solution. And then the fun stuff starts, bolts. And bolts are basically the connecting elements that are actually doing something with your data. Bolts is small pieces of software made by developers. And this is actually where our performance testing starts. If you can optimize in that area already, where the data is being processed, it means that your whole big data solution will perform better. You need to be on the engineering side. As I showed earlier, measuring when the whole solution is in place is not going to work. You need to work on this level with developers to see how are you working. And there are some tools that will help you with it. We'll show them as well. Okay, MapReduce job, if you have some knowledge with Hadoop, then you will recognize the MapReduce job. And there are more of these fast data solutions. You have Storm, you have Spark, you have Samza. They're all doing the same thing, but they name things different. I'm not going to dive into that because then I'm going to be very technical. Usually you need to talk with some architect as well to see which solution would fit your business best. But from performance point of view, it's interesting to connect with the people that write this small code that will process the data from these streams. So what you can do before anything is being built, you can already run some benchmarks. You have some solution in place. It's the hardware, the Storm is installed, and you want to know how your hardware is performing. But your application has not been built, the bolts have not been made, everything is like sprint 1 in your project. And in that case, you could already run some benchmarks to see how is my infrastructure performing. If I need to process 10,000 messages a second, and I send them with this benchmark, and it turns out that my infrastructure can do only 5,000, then there's work to do. I mean, if the benchmark already comes up with lower values as what you will be expecting from your application, there's work to do. And so I put some links here. I'm sure the presentation will be available after the session as well. Yes. Yeah, so you could always download it and check these links. If you're using Hadoop, that one comes with benchmarks as well to test various parts of the Hadoop solution. And it's something I really advise, especially if you're using a cloud solution. I would really advise, if you need to do performance testing, run those benchmarks, see what numbers you get, and see how it compares with your target values for your project. It also means that you need to have requirements. And I know this sounds awful in Agile, add requirements, but you need to think upfront. Sprint 1, you might not have the idea, oh yes, we will be producing 10,000 messages a second. But this is something, when you start designing your infrastructure, and this is something I see going wrong in Agile projects as well, is that there's not enough attention to architecture. One of my projects was for a large customer in the Netherlands. They offer car insurance, and if your car breaks down in another country outside of the Netherlands, then you have insurance for that. And one of the requirements of that was that every case you should be able to add attachments. Because if your car breaks down in another country, you get someone that tows away your car, you go to a hotel, garage, everyone sends invoices. Maybe you have some pictures. So this was known from the beginning. This was being built Agile. So that you just choose some database, and after sprint 15, where there was a lot of functionality built and we had some things we could do, we could execute a business flow, we came to the conclusion that with 20 users, it was already too slow. It was taking too long. And in the summertime, when most people travel and cars break down, they had a prediction of 200 users. So with 20, this was not going to work. And it turned out that the database model they'd chosen to store all these attachments was not correct. It was not suited to store all these attachments. So the requirement was known from day one. And someone said, oh yeah, we need a database because we need to put these attachments. They never had in mind, how many cases do we do a year? Around 20,000. How many attachments every case has? 3, 4? Okay, so we need to store 80,000 attachments. How many users we have? 200. Every user in this call center was required to deal with 20 cases an hour. 20 cases an hour. That means he has only 3 minutes to serve the customer if the customer has a question. If it takes 1 minute to just get the data of each case on your screen, that's too slow. It's not going to work. So the call center will produce less cases, can help less customers. Customers will be in the queue longer, will not be happy, get frustrated. And so this was one of the big mistakes, that the requirement itself was known, but in the Agile it wasn't, in the wrong database was selected. So we had to use another database that could do these requirements, and we used 2 full sprints only by rewriting the code so that we could use the other database model. And this was just a relatively small application. This was not a big data solution. So if you're going to this stuff, it's really important to do some benchmarking before you start deploying everything. And once your application goes live, what's important then is to do production monitoring. And this monitoring is closely related to DevOps, feeding information from production back into the the one slide. Here's the monitoring. Okay. So this monitoring is closely related to DevOps. Get information back from your production environment and feed that into your development. So I put some tools here. You have Nagios, Dynatrace. Dynatrace is APM, it's Application Performance Monitoring. It's a commercial tool. I'm currently using it within my project. Splunk. You can download a version, play with it, and it's also a commercial tool. And you have a tool that's specially designed for Hadoop. So part of performance testing in this kind of environments is also feeding monitoring data. As soon as things go live, feed monitoring data back into the development cycle, monitor what's actually happening in production. Well, another very interesting piece of software that was released this year by LinkedIn. It's open source. It's called Dr. Elephant. And what does this elephant do? Well, you have your developers that write these small scripts, as I told you earlier, these jobs that will actually start processing this data, do something with it, and then it gets displayed on your dashboard. And you want to catch this bad, if it's bad written, if it's not really performing, you want to catch that before you deploy it on your big data cluster, because once it's running, it will be consuming resources, it will slow down your system, and people still want results, so they just keep it running. So what you would like to do, I'm getting popular here. I will need to turn it off. So what you would like to do is to test these software before you deploy it in production. And this is exactly what this Dr. Elephant is doing. It's analyzing these batch jobs, these scripts that your developers make, and if they not really up to snuff, if they predicted to be slow, then they get refused. This is what LinkedIn is using in their big data solution, and it's now open sourced, so you can play with it as well. And I really advise to, if you in this big data, to have this kind of things in place to. This is really bad. Someone is bugging me too much. Okay. To have this kind of solutions in place to catch bad performance before it goes into production. Another important part you would need to test for your performance in big data is scalability. We're using cloud-based solutions, and it's very easy to scale up or to scale down. In the past we had a physical server, and you couldn't scale up so easily. If we found that performance was not really good, okay, we need to buy another server, a physical server, it needs to get installed. And nowadays with Docker, you just spin up a new container and you have additional resources. But it also means that you need to test that your application is really utilizing these resources. Because, yeah, if I spin up more servers, but they're not being utilized because it's not really coded in a way that it's using this additional capacity, then it's not really useful. And scalability from a cost point of view is very important. I did a project for a Dutch train company, and during the daytime, they have 20 application servers running. Because people, they visit the website, they want get information, buy tickets. But in the night, they have only 2 application servers running, because not a lot of people take the train at night. And so this kind of scalability, you need to test from a functional point of view, but also from a performance point of view, that if I scale up to 20, is it being utilized? And if I scale down to 2, is it also still working correctly? In this area of virtualization that we are currently living, scalability is very important, and it's also cost driven. Having two application servers means you pay less to your cloud provider. No. I think this speaks more or less for itself. Yeah, it needs to be easy to release, monitor, tweak. This is the road we are heading to with DevOps. You build something and it's almost directly, it's being tested automatically and it's being deployed in production. And also you want this scalability to make sure that it will perform when you need it and you add some more resources. And this is basically how I do performance testing on big data. Architecture, get involved in the project, find the requirements, test the infrastructure, use Agile, use DevOps, and also feed information from production, real data, feed it back into the Agile team to do additional performance upgrades, changes, new requirements, and non-functional requirements. Good. So, being a performance tester, performance architect is very interesting. You're the spider in the middle of the whole solution. You do the performance testing, you're involved with development, you do production monitoring, platform engineering, you do modeling, simulation, capacity planning. So it's really a job I enjoy, and it's good fun. You're connected with everyone. It's much broader than only being, for example, a developer. So this ends my presentation. I think we have a few minutes left if there's some questions. So, Baris, this one is for you. You recognize this bridge? It's your hometown in Istanbul, yes, it's a very beautiful bridge. So, yes.
So how do you know that we generally say that you can have the benefits of performance testing if you do it on lower level of testing.
Yes.
But we cannot be sure about the outcome. So performance testing is an activity that needs to be done on higher levels as well. So like after you release the product. But in the real life, we don't have test environments, just like our live production environment.
Yes.
Really,
This is what I was showing as well. If you go into this big data
how
stuff.
to scale your results. For example, you run your performance test on a very limited environment, but you cannot be sure that what's going on the production system.
No, and you know, these big data solutions are usually consistent of nodes, and so you have one node where you do your testing, but in production you might have 10 nodes. It's too easy to say you will have 10 times the performance, but you can do some calculation on that. And the other thing, what I say is very important to do this production monitoring and get feedback from production about the performance. You need to have this in place. It's another way of thinking, because we can't do end-to-end performance testing on these very big environments. You can't. This is a very valid point that you raised. And that I fight this on two levels. One is on architecture, one is on development level, where we do unit testing also for performance. And we can have a small test cluster and look how it's performing there. And that's exactly what Yahoo doing with this Dr. Elephant. They take this code, put it on a small test cluster, say, okay, if it's not performing on this test cluster, it won't be good to perform on production as well. And so it's a completely different approach than the old school performance testing where you just have a very big test environment. Yes. Thank you. More questions? No? Okay.